Okay, good evening, everybody.
Good
So,
evening.
Madhavi, hey, show me.
Yeah, uh, I have customer table and there is one column ID, but I want to change I to customer ID,
So you
and
want to
I
change what?
am
Sorry?
trying. Yeah, I have table customer
Okay,
and there is one column ID,
right.
but I want to change ID to customer ID, and
Okay,
I am trying
right,
give an alter command,
right.
but something wrong.
Sure, sure. We'll look at it today.
Okay.
Okay. Um,
Venkat, one quick question.
yeah.
After the class, although this library thing is not important, but I have done it in a certain way. I mean, using polymorphism and all that. So after the class, can you just spend a couple of minutes to see if my strategy is fine or not?
Sure. Okay. Yeah.
But
Great,
any
great.
time, if you want to see in the beginning, that's also fine.
Yeah,
Not a problem.
yeah, yeah.
Whenever you like.
Okay, yeah. Okay, so let's get started then.
Yeah.
Just give me 1 minute. Okay. Sorry. So, we talked about the database, relational database in particular, and then how the data gets stored in relational database tables, like a columns, rows and columns. And we created one table called customer, inserted few rows. So this particular table customer, so we created a schema. So schema is a logical place where we store all the related database tables. So here we have ID, first name, last name, address, city, state, zip code, etc. So one of the points I wanted to talk about today is constraints. So constraints. See, when we create a table, so you don't want every column to be nullable. Nullable meaning, by the way, it's the same meaning. Null means nothing. Okay? So null means not having, nothing. So this is null in database also. Oracle database and several other databases also, it has the same meaning. So by default, when you create a column, by default it is nullable, meaning you don't have to insert a value for that particular column. But there may be certain very important columns like customer, right? In customer table, you have ID. You don't want to insert a null ID here, and you have first name, and first name definitely you don't want to insert, and then last name definitely you don't want to be null, right? So probably middle name, not everybody will have middle name, so this can be null. So this can be null, this can be null, this can be null. So how can you specify that when you insert data into that particular database table, database itself will throw you back error saying that, hey, sorry, I cannot accept null in this particular column. How can you do that? Well, that's where the constraints come into picture. The constraints come into picture, and one of the constraints is null constraint. Okay, there are few constraints. One of them is null constraints, nullable constraints. I mean, meaning you can make sure that it is not null. Okay, you can definitely do that. And there is one more constraint called unique constraint. Okay, meaning customer ID. You don't want to assign the same customer ID for two different people. Every single customer that we maintain in our database should have a unique identifier. Agree? So that you can achieve it by specifying that that particular column should be unique constraint, should have unique constraint. And now there's something else called check constraint. In check constraint, you can say that, let's say there is a customer table. In customer table, there is a column called sex. This one can be either male or female. That's it. You don't want to put, if you put A or any other characters other than F, M and F, it's invalid data, right? You don't want to have invalid data in it. So for that, you can say that, hey, when data is inserted into this particular column, then make sure that this has one of the values that I'm providing it. So it's not null constraint, unique constraint, check constraint, etc. And in database, there are certain crucial fields that are both not null, and obviously this is not, right? So there are certain columns, the most important columns of the table, they should not be null and they should also be unique. The best example is customer ID. Your customer ID cannot be null. At the same time, your customer ID cannot be unique. If you have a situation where a column is not null and unique, you don't have to mention that, hey, I want my ID column to be not null, I want my ID column to be unique. You can rather say that there is another constraint or implicit constraint called primary key. So when you say a table has a primary key, that means that particular field should be not null and it should also be unique. And the golden rule of thumb is that every table should have a primary key. Every table should have a primary key. When you design a table, make sure you have a primary key. Even if you don't have a scenario to use it today, but still, it's always a good design to have a primary key in a database table. Okay? So in the case of customer table, your ID should be primary key. In case of your orders table, orders table, your order ID should be, or here also we can change it to customer ID. Your order ID and the customer ID, this one also should be primary key. And this particular order ID, database will make sure that it is not null, and database will also make sure that it has unique constraint. Okay, so that's about the primary key. Every table should have the primary key. Now let's talk about, first let's go ahead and put not null constraint to our ID, or let's go ahead and put not null constraint to your let's go ahead and put it. Let's go ahead and we created this customer table, and in the last class we created this customer table, right? So now what we'll do is or we can start from beginning, not a big deal. How do I get everything from customers? Select star from customers, all the columns, all the rows, right? Control enter. Okay, these are all the 3 customers that we have. We have seen that. Now these are the column names: ID, first underscore name, last underscore name, etc. Now, if you want to look at, if you want to describe this particular table, you can say describe DESC and then customer. It will describe the structure of the table. Okay. Now, if you look at it, this ID is not null, and then it's of the type number 38. First name, there's nothing. Null, nothing meaning it can be nullable, meaning you can insert null into first name at this point. But does it make sense to insert null as first name? I don't think so. There shouldn't be any customer without any first name. There shouldn't be any customer without any last name, right? Address, city, state, zip code, you can argue about it based on your business rules, right? So how do we, once the database table gets created, how do we change it and make it not null? How do we make it not, how do you add not null constraint to it? Okay, that's where this one of the DDL commands come into picture. Alter table, like how we have a create table, drop table. Similarly, we have alter table customer. Okay, and then we use one of these statements. Modify, if you are modifying the column name. So modify first name. You give the column name that you want to modify, and then you define it now. Again, so still varchar 2, or you can change the size if you don't. If you think 20 characters is not enough, go ahead and change it. And then now you can say not null. Table customer altered. Now let's go and describe it again. Hey, now see, first name is not null, and then it changed from 20 characters to 20 bytes to 30 bytes now. Make sense? So this is how we specify that it's a not null. Now, right? Now we can do the same thing for last name too. Obviously, every customer should have a last name too. And it should be 30 characters, sure. And then we can describe. See, now this guy is also not null. And I want to make sure this ID is primary key. ID is primary key, meaning this should be a not null and then also unique. Then you don't have to mention those 2 constraints. Rather, you say it's a primary key. It's more, the primary key is always the most important column of the table. Okay? We can say alter table customer, modify ID primary key. That's it. Table can have only one primary key. Oops. Modify ID integer. Okay. And table can have only one primary key. Let's look at it. Maybe it's already a primary key. Let's refresh it. You can't be a null. And then column name, data type. You can go to where are the modify ID integer primary key. That looks good. You can only have, I was playing with it, just table can have only one. Okay. If you remove the extra primary key, which one is that? How come it doesn't show it? Okay. Oh, actually, do I have the previous query? I wanted to drop it and do it, but which one is the primary key? How come my describe doesn't show that? Okay, the ID is, why are you not showing it? SQL error or a table can have only one primary key. Alter table customer, modify ID integer primary key. Why does it take it? Oh, by the way, table can have only one primary key. Did I mention that? If I did not mention it, every table can only have one primary key. Okay. This one I do not see. So you can have any number of not nulls. That's not a problem. And ID is correct. Alter table customer modify ID integer primary key. Yes, you are correct. This guy is not showing properly. This SQL star plus. Okay, let's. We don't need to recreate it. Oh, anyway, we'll create a new table, and we will create new table. Let me show you the primary key for hardware, but it's surprising that it doesn't show here. I'll show you in a minute. Okay. Constraints. Let's look at the constraints. Hey, there is a primary key constraints. See the primary key constraint on what? Oh, there is a column name, ID, column position. So there is already a primary key constraint here. Okay. So what we can do is we can delete this constraint using drop constraint invalid drop option. Okay, okay, let's look at alter table customer drop any. Yep. So table altered, drop constraint has been done. Now let's go here and then look at it. Yep. Now ID can be not null. I mean, before the class I was just playing with it. So right before. So ID is not null. First name is not null. We can actually take out this guy too, because this one we did not create it, right? So that's by. Yep. So we have the first name not null, last name not null. We have two constraints, right? Now, let's do, what are we doing now? Okay, alter table customer modify ID integer primary key. Now table has been altered. Now, if you describe the table, look at it. So ID in the null, it is showing only not null. But actually, if you go and describe this table, see here, this guy, this ID has a primary key. So primary key ID, and it's saying this particular customer ID is primary key, meaning this one is not null and unique. Every table should only have one primary key, by the way. Okay, so that's about primary key and not null constraints. Let's talk about. So before I talk about joins or anything, okay, how about renaming a column? So I want to be able to rename a column of a table, okay? So describe customer here, I have ID. I want to change this to customer ID. Typically, the convention in database world is that underscores, right? As I told you. So your table name underscore ID is typically the primary key. You go to any project, typically you will see this kind of convention as your primary key. Okay? Let's rename it. How do I rename it? Again, it's the same statement. Alter table, customer, rename column ID to customer ID without changing anything. Table customer altered. This is the statement you need to give. Alter table customer rename column, and then whatever your old column name to new column name, and then now you describe it. You will get the customer ID. Not now. Okay. Now look at here also. Where is that? Columns, customer ID now. Who Madhavi asked this question, right? Oh, font is very small.
Yep.
Oh, I know. 1 second, guys. Okay. So this is the bigger font. Sorry about that. So we talked about alter table, modifying this to be not null, and then we also talked about primary key, and then we also talked about okay, this is how you can drop the constraints if you know the constraints. Okay, so how do I get all the constraints? Well, here, go to constraints here. So you can get all the constraint names. So this one has a check constraint, primary key, and then see, first name not null, last name not null, and primary key. So that's how, if you know constraints, you can drop constraints from a table. And this one is nothing. What else? This is how you rename a column from old column name to the new column name. This is fantastic. Now, how do we delete a table and recreate it? Okay, so let's get the script, because once we drop it, we will lose it, right? So let's go here, and then do we have the SQL here? See here, if you go to SQL section, you can get the whole the actual SQL script. Okay, so it just adds a lot of stuff that we don't care about it, but let's get all of this information, and then I'll show you how we can drop it. So create table. We don't need this one also because we are already in this schema. Customer, I know it's a little bit, it's generated. Okay, this is all generated by your SQL developer. Number, see here, we can just use the regular, our own stuff, integer, right? So first name, varchar to the divide, not null, enable, not null, enable. So address, varchar to 50, city, state, zip. Okay, this is good. So now let's get the data also. We should be able to export the data also, actually. Right click and then export. You can export all the data into various formats. So if you want all of this data to be in a SQL, then you can get that one as well. Let me look at it. Oh, you got the total script. You got the complete create table script, and then you also got the insert script. Insert into this one, values, right? So you got this one also. So let's save these guys. Okay. Now how do I delete a table? Just say drop table customer. That's it. Okay. And now if you try to get everything from a table, if you try to select, obviously you will get this popular error message, table or view does not exist. Okay. Now this is how you drop a table. Drop table name, and then let me create this table, and then I can insert this guy. I can insert these rows there. See how easy it is. And then if I do a select start from customer, I get my data. Make sense? Now I wanted to show you one more thing. I'm dropping the table here. See here, create table. You don't need these double quotes. I know it's coming automatically from the script. You don't need here also the double quotes, okay? But it doesn't hurt to put it also. So, you know, whatever you like. Customer table, create table customer, and then customer ID integer. If you know a friend that this is your primary key column, then what you can do here is that in your create table itself, you can say that, hey, this is my customer ID integer and primary key. You can say that, okay? And then first name varchar 230 byte. You don't need, see, this is all. We don't need all of this actually, okay? And then you don't say not null enable also. It automatically adds up. So see, so at the time of creation of the table itself, I know that my customer ID going to be primary key. And by the way, Oracle is not case sensitive like your Java. See here, it doesn't matter whether it's uppercase or lowercase. So you can always mix up. So customer ID in of type integer, and this is my primary key. First name varchar 230 not null constraint. Last name varchar 2 not null. Address varchar 2. It can be null if you don't put anything, or you can explicitly put it like this too. So you can do either way. City, 20 characters, to char of 2 state, and then zip code char of 5. That's it. So now table customer created, and then one row inserted, one row inserted, one row inserted. I'm doing control enter, by the way. Okay. See what happens if I try to insert one more time. Control enter. Hey, I get a big fat error message here saying that, hey, your unique constraint violated. Unique constraint violated cause an update or insert statement attempted to insert a duplicate key, okay, on this particular constraint name. This is the constraint ID. Go here, constraint, and then go to constraints, and then what is the constraint that you got it? 7009. So you violated this constraint. You violated primary key. So what does it mean? So obviously it is clearly telling you that it's a duplicate key. So 3 already existed in this particular table. There is a customer out there with the customer ID 3. You cannot insert one more customer or same customer with the same ID. You cannot do it. I'm sorry. So you'll always have the data integrity. You will always have good data. There's no chance of bad data in your database. Make sense? How to modify or delete table based on ID. Can we talk, Shailaja? Deleting a table based on ID. Yeah.
No, sir, not the table with the row, particular row.
Oh, okay. We'll look at it. We'll look at that. That's why when you said how do you delete a table based on an ID, I was like, I didn't get it. The reason is, no, totally fine. I'm just making sure based on your point, I can add one more point so that everybody is clear, right? So your ID is your data, right? Your 1, 2, 3, these are all data. These are rows. And then your table is actually structure, right? So what her point is, now we have a table and we have 3 rows inserted. How do I delete a row? First of all, let me do this one. Select star from customer. Okay, Yuri, Venkat Krishna, Uma. Three customers are there. Now, delete from customer. If I say all 3 guys are gone. What did I do here? Unique constraint violated. Delete. Trusted Oracle configuration, an update or insert statement. Oh, I did something wrong here actually. Oh, in fact, I was reading the earlier error message. I'm sorry. When I did this one here, see here, 3 rows deleted. The rows have been deleted. I'm sorry. What you do is clear, and then you can look at it. So let me insert this guy. Let me insert this guy. Let me insert this guy. And now I'll clear this guy. And now show here, delete from customer. Completely 3 rows deleted. Now I'll come back here. Now I have 3 customers. I want to delete a customer that is having ID 3. I want to delete Uma. Delete from customer where regular where class. That's all. Customer ID. See, it is helping me here. Customer ID equal to 3. That's it. See here, 1 row deleted. And now I have 2 people here. Now I can say that, it's the same thing, same where clause. How you use your where clause for your select, you can use the same where clause. And now you can also say this, delete from customer where customer ID equal to 3, right? Let me do this one. Delete customer where it doesn't have to be primary key. It can be anything, right? Where city equal to Novi. I want to delete customers who are living in Novi. Okay? And now go here and I'm left with only Yuri something. Make sense? And then you can also do anything, it doesn't matter, right? Where you can say address like, you can do, I want to delete customers I want to delete all the customers who are living in this kind of address, 1, 2, 3 %, meaning like, this is like, okay? 1 row deleted because there is only 1 guy that is matched. So before deleting, what you can do is you can actually do a select and see how many people match that particular criteria. So you can do select star from customer where address like 1, 2, 3 %, right? When you say percentage, meaning 1, 2, 3 star, you know what I'm saying? It starts with 1, 2, 3 is what I mean. If I put percentage 1, 2, 3 %, meaning it can start with anything, it should have 1, 2, 3 and it can end with anything, meaning star 1, 2, 3 star, right? And there is only 1 record. You can delete it. Make sense, everybody?
Yeah. Can we undo here? How do we undo? Like Control Z.
That's a good point. So you really can't undo, okay? Because once the way the database is set up here is that we didn't talk about transactions. You don't know anything about, we don't know anything about transactions at this point. But every single statement as you execute, it's going to be inserted or updated or deleted directly in the database. So there is no undo actually. Okay, but there is something called transactions. So there is a concept in database, very important concept and pretty deep concept as well. but we can briefly talk about it. There is a concept called transactions. So now you want to do like a statement one. Transactions are nothing but more than one activity. You want to combine all of them as a single unit of work, meaning if anything fails within that statements, the whole transaction will fail. Okay, now you go to a bank, you have a savings account and you have a checking account, right? Checking account. I'll see here. Okay, now you have 5K here, we have 10K here, and you are transferring, let's say, 2K from $2,000 from savings account to checking account. Okay, if you want to do that, it involves two different operations, right? One is deduct from savings account, right? Meaning withdrawing from savings account and deposit into checking account, right? Or here you can say withdraw. Agree? So you need to withdraw from savings account and you need to deposit into checking account. Let's say this statement is successful. Okay, now this became 3K, and after that something happened while depositing. You couldn't deposit. Okay, then what happens? You will be left with 3K here and you have 10K because the depositing failed. You don't want to be in this situation, right? Agree? You don't want to be in this situation because 2K lost. At any point, either you want to be, you have to have a 5K and 10K as if nothing had happened, or if everything is successful, you want to have $3,000 here and $12,000 here if everything is successful. This is all fail. Okay, if something goes wrong in between, then fail everything. Fail this step also. Fail if something goes wrong here. If any of the steps failed within this particular transaction, then undo the previous things also. That is called rollback. Roll back the previous activity also. Do not commit. Commit and roll back. Commit meaning once all these steps are successful, then we commit, meaning yes, now you go and now everything is good. Now you can save it finally. That's the final copy of it. Okay, if anything fails, then you roll back all the successful ones also, meaning you have to undo it, otherwise you will be in very, very, very bad shape like this, right? You will result in this bad shape. You never want to be in that particular situation. Either you all fail or all successful. This is all successful scenario. You have your 3K here, you have your 12K here. Make sense?
Yeah, so when we try to save or when we try to close without saving, do we get this option commit or rollback? I got this message when
okay, now we got the transactions thingy, right? Now, by default, this one has been set up. Your tool has been set up to be auto commit to true. Auto commit, meaning every single statement, I don't need transactions, okay? And I want you to auto commit to true, meaning as soon as I finish the statement, go ahead and put it in the database directly, okay? You don't need to wait for me. Otherwise, if you disable that auto commit, there must be an option somewhere here. I don't use this one for my work. We use Toad. Most of the people use the Toad. But if I auto commit is turned off, then you need to, nothing will happen here. Okay. So once you insert this, you do a select, you will see it because you are in that session and only you can see it. Okay, you brought up a great point. Now, let me talk about the concurrency. Since we talked very briefly about transactions here, let's say that there is I hope I'm not confusing, but we have this database here. We have person 1 and we have person 2 here. Okay. Now, you opened a session. Okay, you opened your Toad or SQL developer, and now you said auto commit is false. Auto commit false, meaning, you know what is auto commit false? Meaning, hey, until I explicitly commit, do not put into database completely. Okay, they are there in the database, but nobody else other than you will be able to see it. So you execute, you insert, you did 3 inserts here, and this guy, when I do a select here, I'll not see those 3 inserts because you have not committed. Unless you commit explicitly, you'll not be able to do it. After these 3 inserts, if you think that, but you do a select here, you will get it here because you are in that session. It will be only shown to you. And at the end of the day, you can say a simple statement called rollback, meaning, hey, from my previous commit, all the statements that I executed, can you please roll back? Meaning, can you please undo? Then database will undo this automatically. Okay, this person 2, or after that point, even you can't get it. Oh, that's how I lost the table I created. That's comment from Oma. So that's how you lost the table you created. Okay, very well. So at least you're able to connect the dots now. So yes. What you need to do is, after you do this one, insert, whenever you are happy, okay, you just say that commit. Once you commit, now they're persisted in the database forever, and all the other people also can see it now. This person too will be able to see it. It happens if you say that your auto commit to false, but I'm not sure here. Not sure where is the auto commit, if there is a, but there is a feature, small feature. We can check. Actually, in Toad-like ones, there are simple. Or is there a way? See, this is commit, SQL Advisor, auto trace, explain plan. This is rollback. You want to, but there is, by default it is auto commit to true. That is why you are able to see it. Even if I say rollback here, right? Rollback complete, but there is nothing that's out there actually, right? So if earlier also we didn't have anything. Let me insert, and then I see this one, right? And now let me roll back. Now let me go select. Oh, hey, it's happening. So I'm inserting, I inserted, and then I'm seeing, oh, what happened? Did I do something wrong? Oh, I'm not doing a select star from customer, right? Let's do all the customers. Now I'm seeing all 3 customers. Now if I roll back complete now. Oh, so by default auto commit is false for this one. So there you go. Make sense? So actually we play with it typically when we any of the tools like Toad or SQL Developer. Most of the people actually use a tool called Toad. there is a small like a button like one. You just say auto commit to true or false, or there is a checkbox also in the initial one. So, but either way, so that's how the transactions work.
And
Yeah, go
where
ahead.
do you save all the work? Under
Where do
which
you save
folder do you
all of
save
this
all the
work?
work? Like
That is, these are all tool dependents. You can say,
anywhere? Yeah.
you can say, save this as, okay. See this one, local oms.sql. I went to file, save this as, go to desktop. I saved it. Please choose a different name for the file. Okay, why? Oh, because I already have it. That's it. And now go to my desktop. Did I save it in desktop? Where did I save it? Oh, D desktop, right? Yep.
Okay. So
Got
we
it?
can save it wherever we want, right? Not
Oh,
like
yeah.
we go to
Yeah,
this
yeah.
folder.
This is all regular tool stuff, so it doesn't matter. Makes sense? That's it. I think from the transactions perspective, I don't want to speak more than that. Did you guys understand that? So commit and rollback. Oh, by the way, we didn't commit, right? Let's do a commit. So now, how many rows do I have? I have 0. So all of this is confusing me really. Okay, so always clear this guy, because I'm not getting whether I'm not seeing whether my last statement is successful or not. So this is clear. Now how many do we have? 3. Now you try to connect to my database if you have access in the network, security, everything is set up. Okay, if you try to connect to my database, and now at this point when you do a select start from customer, you will not be able to see it because I have not committed that. Now all I have to do is just commit. Now commit. Now it doesn't matter. Okay, now go and roll back. Now you do whatever you want to do it, because there is nothing between commit, right? After commit, everything will be flushed into the database. Everything will be flushed into the database. Make sense? That's about, these are transaction related commands. They are under in SQL. There are multiple categories, right? One of them is DDL, data definition language, modification language, and data control language, your grant and revoke commands here. And then finally there is one more called TCL, transaction control language. That's where you have your commit and rollback statements exist. That's about it. That's about the transactions. Very briefly though, very briefly. There are a lot of, it's very deep concepts. There are a lot of things, transaction isolation levels and transaction demarcations. Briefly we'll see if we can talk about it in again spring. I typically talk about all of the transactions in the EJB context. When I talk about EJBs, actually there is a video, I can give you that. Or we'll talk about, we will anyway talk about Spring transactions, so at that time I'll touch on the transactions again. So anyways.
Venkat, one quick question.
Yeah.
Since you brought up the term EJB, what's the meaning of the exact meaning of the word bean?
It's completely off topic. Okay. So I don't want to touch upon that right now.
Okay.
Is
but
it okay?
EJB means what? Enterprise
Java
means,
yes.
Okay. It's off topic. Okay.
Yeah, I mean it's completely unrelated, so don't want to confuse everybody.
Okay.
Sorry about it, Sean.
Okay.
So after this point, once the recording is off, we can talk briefly. I can tell you in 1 minute. Okay.
No problem. Actually, you brought up the term EJB. That's why I was curious.
Sure. That's where I typically talk about transactions. So
Okay. No problem.
Okay. So now where are we with the original topic? So we talked about all of this alter statements. By the way, we learned about how to read, meaning how to, these are all the DDL commands, right? The data thing, data manipulation. How do you read and how do you delete? We talked about the delete data also, delete command. And how can we update something, right? Select star from customer. We have 3 customers here. And Yuri something. Hey, what's your last name, Yuri? I know you said last time. So your last name is something here. So I want to update it. Let's update Yuri's last name. Okay. How do we update it? So update customer. There is a other command called update. So update your table name. Update customer. Set. Okay. Set last name equal to this one. Hey, what's your last name? By the way, in strings or varchars in Oracle, like how we put it in double quotes in Java, we do it in single quotes. Okay, we do it in single quotes in SQL. Okay, so okay, let's update his last name. Gary. Okay, this is last name. Where? So if I just update like this, right? Everybody will update it because I did not put any where clause there, right? Any condition there. Okay, only do it for Yuri. Where did I say that? I didn't say it, right? Now if you look at it, see, everybody's last name has been changed. That's not our intention. So let me roll back. Now, okay, everybody got whatever their original this one is. So update customer, set last name equal to Gary Luke, where customer ID equal to customer ID equal to 1. That's it. 1 rows updated. See here the result. 1 rows updated. And now you go back, select start from customer. Now you will see Yuri Gavrilik. That's his last name. So that's how you update the records. Now you can update something else. Oh, how do you update more than 1 columns, right? Update customer, set first name equal to Venkata. Let's say I had a typo, Venkat. Earlier I put it as Venkat. Now I put Venkata Krishna. Okay. First name is this one, and then address also I'm updating now to his real address, which is 987 Frank Street. Let's say. I know this is not real, but so you will say set your column name equal to whatever the data is, right? The updated one, comma, second column name equal to, and then his new value, comma. I'm changing his zip also. So zip equal to 99911. Okay. Now I still didn't mention my where class. I need to mention my where class. Where customer ID equal to 2. Right? One row updated. Now let's look at the customer table. Venkata changed. 987 Frank Street changed. 999911 changed. Right? And a small convention to make your life easy while reading it, always do when you have a lengthy statement like this, you break it. Update customer like this, set, and then tab. Make sure you have them in the same tab here. First name equal to Venkata, comma. This is how I do it. This is my style. Zip equal to blah, and then where clause is with everything else. This is how a lot of people do it. So I always first match these guys up for better readability. Okay. So this is how I do it typically. So you can do the same thing. So that's how you update the data. Okay. Any other questions? Yeah, somebody was.
Can we sort?
Oh, good point. Good point. Yeah. I wanted to insert the other table orders and then tie up and then talk about a little bit of join. But these are all good good questions. So let's start. Select star from customer. How do I sort the records, right? Order by. Order space by, order by, whatever the column. Let's say city. Like our comparator, string, you know, we don't have a custom comparators here, but you have only the natural ones. So you have your alphabetical order, Hendon, Novi, Rochester. But what you can do is you can do a descending one though. Okay? You can do a descending, city descending here. Now you can do like this, RNH in reverse order. So, yep. Did you get it? You can do it order by city, and you can do like an order by city, comma, first name, descending. You can do like this too. Okay? So it will do a first city, and then it will do, if more people are there in Hendon, then it will order all of them by their first name descending meaning reverse order, first name reverse, starting with Yuri all the way to Aruna, A, Y, no, Z to A. That's what I meant. You got it here, right? That's about it. And this is about order by or sorting. There is some other clause called group by. Remind me after some time. Let's talk about we'll talk about group by also. This is a grouping. You can use some grouping functions to find out, hey, how many people are living in how many customers are there in Michigan? How many customers are there in Maryland? Okay. So to find out, there is typically in interviews also they ask what's the difference between order by and group by. Go ahead, Uma.
Yeah, you put do group by, you just type there, right? Is that like a comment? Like we put
no, that's not a comment. Just remind me after a few minutes.
No, like how to, if we want to write in this, like not a code, but just a
I'm saying just remind me in after a few minutes. I'll show you with an example. How do you write it?
Oh, okay, I think.
Sorry, are you asking something?
Yeah. See, if I want to write something, like in Java we say, right, we put two backslashes and say this is for this.
Oh,
we just
Oh, comment, huh?
Not a real code. Yeah.
I'm sorry. I'm sorry. I
Put
didn't
two
let you finish.
hyphens. Yeah, this is to comment.
Yeah, this is how you comment it. Yes.
Okay. That's my
I'm
question.
totally sorry.
Thanks. Yeah,
See that? This is how you comment it. So it doesn't, it ignores. Okay.
thanks. Yeah.
So Leonard was trying something and he's running into this issue. Probably everyone is looking at it. I have a problem creating a table. I get a message, no privileges on table space. So you need to grant that unlimited table space to your user. Remember, first you log into your super user, which is your system. Okay, hey, see this one? We have the statement already. Grant unlimited table space to the user. You do that. Thanks, Antenna, for pitching in. So, okay, anyways, that's about it. Now, what we'll do is, before we talk about anything, okay? Let us create a table called orders. This is customers, right? In fact, I like customers better than customer. Okay. Or okay, we can rename the table, or yeah, or we can drop the table and recreate it. It's okay. We just did, Leonard. Okay, so we are talking about the context of Amazon here. So in any retail store like Amazon, they have customers like us. We all go shop there, and they also have some products, right? So some products like books, iPad, iPhone, etc. And then when I buy a book in Amazon, that becomes my order. Order is I buy more than one or more products in a single at a time. That is order. If I buy a book now, Spring in Action book now, that's my order. Once I check out, that becomes my order. Now later evening, 2 hours from now, if I buy a ceiling fan, okay, we're looking for that. So that becomes a second order, right? So everything is different orders. So we have basically customers, products, and orders. So I'm not worried about products that much. We can put directly into the order, but let's talk about the orders, right? So let's create a table called orders. Create table orders. Okay. Tell me. The first one is order ID, right? Order ID should be integer, and then it should be a primary key, right? Fantastic, Leonard. Order ID, integer, primary key, and then order name. Okay, let's say there is a order name. Or maybe there is no order, right? Or maybe there is a order name. I don't know. Order name, let's say, cat 2 of 30, and then product name, right? What? Sorry, go ahead. Yeah, item description.
Order date?
Yeah, order date definitely will be there, but item description or item name, let's say item name for the simplicity's sake, car 2 of 50, okay? And then definitely order date, I agree with you. There is nothing without order date. So there is a data type called date also. And then quantity, huh? Sure. I think that's a very good idea. Quantity. quantity integer as well. And that's good enough, right? So my assumption is, tell me, what do you think? Order number. Shall we put this order ID is a primary key? It has to be unique for every single row here, right? But let's say in one order, if I buy an iPhone and spring in action book, okay, it's possible, right? And a ceiling fan. Okay. So iPhone, spring in action, and ceiling fan. It's possible that I bought all of these three. Then we can insert 3 rows into this order table, right? Or is that a good idea? Or probably no. Let's say no. We'll definitely bring customer. Like who made this order or who placed this order is definitely there, which is a customer ID, right? So who placed it? So order ID, and then we'll say customer ID, right? Customer ID. Customer ID is also integer, but this one I'm struggling with without complicating the things. How can I do it? Or can I say order description here? Order description here, and then I'll say varchar 2 of 100. I mean, here you can say iPhone, comma spring in action, comma ceiling fan, comma. Ideally, all of them should go to products. But I will talk about that because I didn't talk about foreign key relationship yet, right? I will talk in few minutes. Okay. So I think this is good enough, if you all agree. Okay. Customer ID also, it can't be null, right? Okay. And then order description, ideally all of them are not null, right? Everything should be not null, but I'm leaving it like that. Okay, table orders created now. Now, let's insert some data. Insert into orders. Okay. My order ID is 1, meaning, okay, and then customer ID. Who is number 1 there? UD was number 1, or Venkat? Yuri, I think, right? So let's say Yuri bought few items. Yuri bought iPhone, spring in action, and ceiling fan. He bought all of these 3. iPhone, and then, okay, comma separated items he bought it. Okay, so he bought these 3 items. I know this is not a good design. No way I'm saying this is the good design or something. This is just a most basic design. Okay, we will come and improve it over the time. So this is order description, and then item name. Oh, item name now doesn't make sense probably, right? Because we thought we can still correct this one. One way to do it is we can have something called order number. And we can insert 3 different items, 1 for iPhone, 1 for spring in action, 1 for ceiling fan, with the same order number, with the different item names, okay? But they all will have the same order number. Shall we do that way? Maybe that's better. Shall we? Okay. Oh, really contemplating, but that's okay. Yeah, let's drop this table. Orders. There's no good way, bad way. That's why I'm order ID and then customer ID definitely, and then I'll say order number. We'll give them some 10-digit order number, okay? And then item name, order date, quantity. Good. I know all of these are duplicated. That's totally fine. Okay. He bought iPhone, okay? And then his customer ID is 1. Order number is 123. Okay? We generated one order number for him for iPhone, and then Okay. And order number, item name is good. Order date is today's date. Today in Oracle world, sys date, meaning system date. Now is the system date. Now, right? So, and then quantity is, let's say he bought one iPhone. Okay, missing select because we didn't put values here. Oh boy, okay. Insert into orders values. Oh, because we didn't put, I didn't close this guy. Table of view does not exist, is that right? Orders. Okay, table orders created and then one row inserted. Very good. Now let's do. This is order ID. Order ID will be always unique. This is for our records, okay? Meaning for our Amazon records. And same order ID, 123, same customer, okay? He bought iPhone and what else he bought? Spring in Action. It's a book. Same sys date 1 and then here he also bought a ceiling fan. Okay, so he bought these 3 items in a single order. Now let's say that order 4, Uma bought something. This her customer ID is 3 and her order number is 999 and she bought effective Java book. Okay, and she bought sysdate -1 yesterday, and then how many? She bought 2 of them. Okay, good, right? And then let's say Uma bought 1 more but in a different order. Same person 3. Okay, different order number, 989 or 900, and she bought something else. What is that something else? Any other good books? Pragmatic Programmer. Pragmatic Programming. Programmatic Proa. Oh. Pragmatic Programmer. Okay. And then this one she bought it today, and then 1 item, and then yeah, that's it. And then let's say that let's commit this guy, and then Venkat Krishna didn't buy anything. Okay, we intentionally left him like that to see some interesting stuff. Okay, now let me open
Venkat?
yeah. Go ahead.
This is Aruna.
Yes, Sarina.
One question. Can we create composite primary key on order number and
Definitely we can. Definitely we can. But I don't want to complicate the things here. That's my goal.
Okay.
It's definitely possible. We definitely do it. And it's just me here. My biggest goal here is how to teach simple concepts without complicating. That's all. Right? Agree?
Okay. No.
Because once this is done, we want to move to how do we do all of this in Java, right? How do we interact with this database using Java and then execute all of this, right? Now, let's step back here. Oh, these are all the orders that we have. Now, Customer ID 1 and 3, they are fresh in my mind right now. 1 is Yuri, 3 is Zuma. But I wouldn't know that, right? I want their name here actually. I want to see customer name and their order number. I don't need to see these primary keys. I don't care about it really. So I want to see the customer name and all of their orders and their items and when they bought it. Okay? And sure, quantity also. So how do I get that? That is when we use something called joins. Okay, when you have data in two different tables, this is customers table, okay, and this is orders table, and you want to, because customer name is in customer table, because you want customer name, right? And you want let's say I want this one, customer name, okay, and their zip code, okay, and then order number, and then item description and date. If I want this one, customer name and zip code are in this table, right? And then the other ones are in orders table. So how do we get the data from both of them? That's when we use something called joins. Okay, so the most common join, there are a couple of few types of joins, let me put it that way. So the most common one is called inner join. Okay, inner join meaning if this is customer table and if this is order table, they have to have something in common, right? So what is that common? Who is actually mapping the orders table and customers table? The customer ID in customers table is also there in orders table. Agree? So that is what is mapping. So we can use that particular column to join both the tables and get the data from both of them. That is called inner join. So here, in the case of inner join, you get the data here, the intersection part here, meaning all the data that is shared between by both the tables. Okay, so you should have the customer ID in customers table and you should have the customer ID in orders table also. Then you will get all of those customers and their orders, okay, in such a way that it exists in both the tables. Customer ID exists in both the tables. Then you will get the data, and that is called inner join or a simple join. This is called inner join or also called simple join. Okay, how do we do that? This is how we do that. And typically we do this on a day-to-day basis, so you need to be able to do this. Select star from customer, comma. We need to get it from both of them now, customer and then also orders. Okay, now where, this is important, where customer dot customer ID, right? Customer dot customer ID equal to orders dot customer ID. So what we are saying is, go take the customer ID from customer table and go match with every record in orders table, and if they exactly match, give me those records in both of them. It has to exist here, it has to exist here, and then give me everything. If you don't want everything, you can say that customer dot what do you want here? From here you want their first name, okay, and then you can say customer dot, you can get their last name, okay? And then from orders table, you can get their item name, item name, and then orders dot order date. You can get all of these 4 information. Now look at it. I missed the semicolon there. Now look at it. This is how it is saying. So Yuri, he bought iPhone because his because we are storing all of his items in order table as a row, right? So you bought an iPhone 14th April, that is today. Now if you look at it, if you want the order number also, it makes sense, right? Now that gives you some idea. Order number. Let's do that. See here. So he bought iPhone, spring in action, ceiling fan, all these 3 today with this order number, the same guy. And now Uma, see, we got her last name too. Uma ordered effective Java yesterday as part of the order number 999. And then Uma bought pragmatic programmer today as part of the order number 900. So we are joining 2 different tables and getting the data from 2 different tables or more number. This join can be it can be, it can be very, very complicated too. You can join 10 different tables. Totally fine. Make sense? Agree? So that is about this inner join. Before we talk about other joins, actually I need to mention something here. We talked about primary key here, right? So now let's talk about two tables that we have, 2 important tables that we have here are, one is customers, and the other one we have is orders. So we have customers and orders. Here we have customer ID. I'll say C underscore ID. Orders also. Here also we have C underscore ID. Let's say we have the customer IDs 1, 2, 3, 4. Now, what if I have in the customer ID column here, what if I have something like a 9 and 11? Does it make any sense here? Does it make any sense? In my orders table, I have customer ID as 9, but there is no customer associated with that. But we are saying this is an integer. I can put any integer, right? I can put any integer. I can put 9 is a good integer. Why can't you take it? Well, but there is no customer here. So we should not accept any customer IDs that do not exist in customers table. How do we do that? Well, that concept is called referential integrity. That concept is called referential integrity. Meaning you need to maintain the data integrity between these 2 tables as from the standpoint of customer ID. So every customer ID that you have in order table must exist in the customers. Otherwise, I'll not be able to map this order to the corresponding customer, right? I'll not be able to say that this was ordered by Yuri, this was ordered by Uma. I'll not be able to say that. Make sense? So we need to maintain the differential integrity. When we reference this one, we need to maintain the integrity. And we do that, there is something called foreign key. There is something called foreign key. So customer ID is the primary key here, right? So here In customer table, we have this customer ID primary key here, right? This is primary key. In the main table, he's the primary key. Now, wherever you are referencing this guy here in orders table, if you now here, I have a column name called cust underscore ID. It doesn't have to be exactly same. I want you to understand that point. This column name can be anything here, but all you are saying is I'm storing the customer IDs of the customers that are from this particular table. So I want you, meaning database, hey, I want you to maintain the referential integrity between these two tables. Meaning I want every customer ID that is inserted in orders table in this particular column, I want you to make sure that every ID exists in the main table, which is customers table. So if you try to insert an order with 9 or 11, because 9 and 11 do not exist in the customers table, I will not let you insert into that. How do we do that? Well, when we define this particular table, what we say is we define this as a foreign key here. And this is called a foreign key. This customer ID is a foreign key that references customer ID in customers table or customer table. Once we establish that relationship, what we gain is that we don't have to worry about it. From this point, when you just accidentally try to insert a customer ID that does not exist in customer table, then database will slap you back and say that, hey, I have a referential, I need to maintain the referential integrity. So I don't have this particular customer ID in the master table, in the main table, which is customer table. I'm sorry, I don't let you insert this one. This is for your own good because you can't correlate the data. You can't associate the data, right? So you lose the integrity of the data. So I will not let you do that. So database will handle all of that. All we have to do is just say or just tell the database that, hey, these two are linked. Hey, make sure every customer ID that's inserted in orders table exists in the master table, which is customers table. Make sense? That is called foreign key. So this customer ID here in the master table is primary key, but this guy is acting as foreign key in orders table. That is why you will not be able to insert the IDs that do not have in the master table. Make sense? And how do we define that? Well, this is how we define it. Let's describe orders table for a second. We have the customer ID not null, right? So now this is how we do that. You can definitely specify this during your creation of the table itself. Okay? You can definitely do that. You can definitely do that. In fact, if you want me to, I can show you both actually. We can show alter table orders modify. Okay? Customer ID integer. Obviously this is customer ID integer. References customer of customer ID. So this column here references customer ID column name in customer table is what we are saying. Now table orders altered. Let me commit that guy and then now let's go to orders and then now see here. Now this is what we just said, foreign key. So it references the primary key in the, see here, it references the customer ID in customer table. So now Let me do this one. Select star from orders. I'll show you the magic here. That's all we need to do. All we need to do is, hey, please help me database. This column here should match with this guy. Just help me with that guy, whenever I accidentally do it. So these are the orders, right? Now let me do this one. Insert into orders. Okay. Values 6. Order ID 6, and then let's say customer ID 19, my imaginary one. I accidentally did it or intentionally did it. I mean, obviously we do it, accidentally only. My order number is this one, and I bought something. Whatever. Right. Right. Now let's look at it. Did I erase everything? Yes, I erased. Oh, big fat error. See here? Error starting line 39 in command, insert into blah, error report, integrity constraint, this particular constraint name, violated. Parent key not found. Sorry boss, I couldn't find a customer with the ID 19. It is helping you. A foreign key value has no matching primary key value in the master table or parent table. That's what parent key not found, right? In the parent table, it couldn't find a primary key with this number 19. Make sense? Now, I accidentally did that. In fact, Venkat Krishna did it. So he's number 2, right? Now it happily lets me insert. See here, 1 row is inserted now. And now you look at it, you get it, right? And I committed. Now you go to this, where is our orders? Where is our orders? Join query. Oh, maybe here? No. Okay, this is here. See here, you're getting everybody's. Now the newly created row here. He bought at first Java with this order number. Make sense? So that is about foreign key. It helps you a lot. Use it. Okay. Now we talked about simple join or inner join. There is something else called outer join, or two specific joins there are called left outer join and right outer join. In fact, they both mean they both mean the same. It's based on your preference. So this is what I want. Oh, in fact, we just messed up. Venkat Krishna, I intentionally left him. Okay, let me look at the orders, right? I don't want Venkat Krishna, so I'll just delete this guy. Delete from orders where order ID equal to 6. So I just deleted him. Okay, fantastic. Now what I want to do is, I want to get all the first names, last names, and their item name. Let's say I'm not interested in order date. Okay, just for my 2 order numbers. Okay, this is good enough. I don't care about when they ordered. Now, even though, see how many customers do I have in total in the database? I have 3 customers. I have Yuri, I have Uma, I have Venkat Krishna. In fact, Yuri was 1 ID perspective, Venkat Krishna and Uma was the last. So we have 3 people, but it's giving only 2 people. Why? Because Venkat Krishna, he did not buy anything. His customer ID is 2. If you look at it, he doesn't have any orders, right? So that is why it is giving you only 2. See, if you look at my diagram here, see here, this is customers table, This is orders table. I'll put it in different colors probably. Okay, this is customers table and this is orders table, right? There are more customers. There are more customers here, but I'm not getting all of them because they don't have any associated orders. I will only get the join. I will only get the intersection of these two tables if that particular ID that I'm putting on, which is customer ID in both the tables, if it exists in both of them. But it does not exist in the order table, right? That is why it is not giving me that particular customer. Let's say my requirement is that, you know what, I want all the orders. I want all the orders, but obviously every order will be associated with the customer. So there is no doubt about it. So, but in addition to the orders, I want all the customers even though they did not place any orders. I want the orders and I want all the customers even though they did not place any orders. Then what will happen to this item name and the order number? What will I get as? Well, they will get as null. But I want their first name and last name. Whatever the data that you get from customer table, I want it. Of course, I totally understand that because they have not placed any orders, all of that. For all these records, I will get null here. I'm okay with that. That is when we use the outer joins. Meaning, all we are saying here is that customer is red, right? So I want all of this data. Essentially, what I want here is, I want all of this data. Even though I understand totally that there could be some people who have not placed any orders, but I want all of these people. How do I get it? Well, that's where the outer join come into picture. So now we'll say that. So we can get all of this, okay? Now, I want all of these details from customer, okay? Now customer, I'm not joining both of them. I'm doing a left join, okay? See here, it's actually helping me. So I'm doing a left outer join. I want from customer left outer join employees, okay? On, this is part of the syntax, on customer dot customer ID equal to, this is orders, right? Thank you. I know I've, thank you. Orders dot customer ID. Okay, so here what I'm saying is, hey, I want all the customers. In fact, the reason they call a left outer join is there are two different tables, right? Customer and orders. I want all the people from left table. That is why, meaning I want all the people from customers. That is when, that is why it's actually called left outer join. Now you observe this one, you are getting now Venkat Krishna also. Even though he has not placed any orders here, you got null and null, okay? But you got his first name and last name. Make sense? In fact, you will do a left outer join in such a way that whatever the table that you want full, see here, whatever the table that you want full, which table you want full here? Customers. So put that guy on the left side and then say left outer join, meaning the table on my left I want everything. But from table from right, I only want the intersection. From right table, from orders perspective, I only want the intersection. Okay, this is called left outer join. You do exact opposite, meaning if there are any orders, I know in this particular context it does not make sense because we set up the foreign key relationship, okay? But if there are any orders that are not associated with customers, then you can do the same thing. You can put orders here and you can put customers here, and that is your left outer join. And the exact opposite, you will get the same results. The exact opposite is right outer join. You just make sure that now what you're doing is, hey, my orders are now right outer join, okay, customer or customers, where order dot customer ID equal to customer. The only difference is that it's actually you are saying the right outer join. So hey, I want a full list from my right side table, which is customer, okay, and I want join from orders. So I want the intersection from this table, but I want full from this other table. So that's actually right outer join and left outer join. It's pure preference wherever you put it. On the left side, if you want complete left side, then you call it left outer join, and you reverse it and you say, hey, I want completely from right side, then you call right outer join. And there is something called full join. In that full join or full outer join is nothing but I want everything. I want the union of both of them. Then I want all the orders even though the associated customers do not exist. I want all the customers even though the associated orders do not exist. So I want full. Make sense? And that's about it. Anything else? We can write somewhat complicated queries if you like. So let's say this is, small point I wanted to mention it here. There is something called LAS. There is something called LAS. See, when we do join, here, so when we do join here, either left outer join or right outer join or inner join, whatever the join type is, right? When we join this one, right? So here you are saying the customers and orders here, and you are saying full table name dot your column name, full table name dot your column name, right? Rather than specifying the full column name, what you can do is you can use something called aliases, meaning you can give a small alias to your table, customer C, orders O, and then you can just say you are giving one more name to that. That's all. Alias is nothing but one more name, right? So that's it. C dot customer ID equal to O dot customer ID. Simple. Oh. Orders dot, there is no orders here now, right? So yeah, in your select query also, you can simplify much. C underscore first name, C, orders is O now. You don't need to mention the whole, okay? This is O. And by default, your table name is used as alias name. But we gave a simple alias here so that you don't have to put the whole table name. This is alias. And now, there is since I'm talking about aliases anyway, so C dot first name, right? So by default, it shows the column name here. But if you want to see here, the result, are you guys seeing in the result here? In the result, if you look at it, first underscore name, last underscore name, item underscore name, order underscore number, right? So, but if you want to display something else, like let's say first name, like that, okay? Oh, I have to give, let's say first name to display. Okay. So you can give some aliases for these column names too. So sometimes the database column names may be messy, meaning people may not understand. That's not user friendly. But you can give some alias here. C dot last name space. You can give your friendly name, friendly last name. Okay. You can give alias here also, like that. Make sense? See here. First name to display, friendly last name, item name. If you don't give it, then your column name will be taken as that. Okay? So that's about it. That's another small point. Okay. Now, Antenna is asking a question. What is the difference between full join and union? So we talked about full join, right? And there is another statement, another, what do we call, another construct that we have here is union, meaning you just write one query here, select blah, 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 okay, okay, you just say union, select blah, 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 okay. The difference between full join, in the case of full join, you are getting everything from these two tables, right? Okay. Everything from these two tables. And union, the difference is that the tables can be entirely different. This one may be, let's say that you are actually storing the customers, okay? You have two different databases or database tables in two different, let me not complicate. Let's say for some reason we are storing customers in two different tables. All the internal customers are stored in one table. All the external tables are stored in one table. Okay? Or let's say Bank of America bought some other bank, right? It bought some time back First National Bank, let's say. This is BOA, Bank of America. Let's say Bank of America has these customers in this particular table, and obviously First National Bank, it's a different bank all these while, and they are maintaining in their own database and they are getting their own tables and everything, right? Let's say it's here. Now, their table names are different here. Everything is different here. I mean, table name is different. Your column names are different. Everything is different. Here also, same thing. Even in that case, what you do is write one select query here. Write one select query here from your Bank of America. Write another select query here, Bank of America. The only thing that needs to match is both of them have to have the same number of columns, okay, and same column names. Then when you do a union, you are getting it completely, but under the hood, your where clause, everything where you are getting from, everything can be entirely different. So that is about union. But here I'm talking about full join. We are talking about two tables, okay, that you want to join. That's all. But here the source can be different, where clauses can be different, two different lists. You are combining it and giving a unified view to the column. That's all the union means. Okay? two different lists in Java, you're combining both of them and giving a unified view. That's all. So that's about it from the database side. You're welcome. And I wanted to conclude here. There's a lot more to database, definitely, but I want to conclude here. And I can see here database concepts 1, 2, and 3, 4. I think 1 pretty much the same. I covered it completely, I'm sure. 2 also, I'm sure I covered it. Maybe not. Take a look at it. But 3 and 4 definitely, all of this stuff, watch these videos. But it doesn't have to be now, because we need to stay focused on Java. But before you actually go for interviews, you need to watch these videos, need to be comfortable. Come back after a month and a half, 2 months. Once we are done with this course, you come back and watch it. But before going for interviews, you need to be comfortable with these database concepts also. Okay? In the next class, I want to jump into our how do we use Java to connect to database. But there are a lot more database concepts. Even interviews, they expect quite a bit. Okay? But I talked, as I said, every batch I take new stuff. So in the last batch, just last batch, I took this stuff and completely went to the in-depth details of every database object possible. Indexes, sequences, procedures, functions, packages, triggers, everything. So take a look at it. Okay, it's a great stuff. I highly recommend. But now I also want you to stay focused on Java. So this one, if you can anytime catch up on these videos and familiarize yourself. But while we are with Java, I want you to focus very well. Whatever we talked until this point, the database concepts are very, very, very important. Don't get me wrong, because we are going to need all of these concepts we talked today in the very next class and the following class. No doubt about it. Okay? But don't go too much, don't go down too much into database path at this point. Let's stay focused on Java and then understand as much as possible, because these ones, my videos are always there. You can come back and watch. Okay? Anybody has any questions?
So Venkat,
Yes.
so next day you are teaching JDBC and DAO, right?
You got it? Yep.
Okay. Okay.
So I'll show you how to connect to the database using Java. That is JDBC, Java Database Connectivity. And then once I talk the basics about JDBC, and then I'll talk about data access object. It's a design pattern. And then I'll talk about, hey, why do we typically localize all the database calls into one class, and what's the advantages of it, and it's a pattern. So that's what I talk about in the next class. If you guys don't have any questions, that's all.
No, I have one. I don't have a question, but I just wanted to just take a quick look at the work that I did, the implementation and the interface and all that for the library program.
Okay.
That's all.
Okay.
So if you wanna take a look at my, make me the presenter.
Absolutely. But shall I put time box?
Meaning?
6 minutes. Okay.
Not even that. Not even that.
I'm just.
See what I did?
Oh.
Can you see me now?
Yes.
Okay. See these 4. Forget about them. AAA, BBB, these 8 programs. These are my actually data entry, member data entry, and catalog. Catalog means list of books. Data entry programs, and forget about that. That's not so important. So basically 2 members, two tables based on member class and catalog class.
Okay.
Okay. I'm calling it table here, but they are actually files. So I'm not showing you all those details because then 6 minutes will be over.
I'm fine.
But
Yeah.
hang on a second, it's just coming up. Okay, let it be here. The main thing what I've done is, what I'm doing is I've written the main program, which is this one,
Mm-hmm.
to really just extract files from there, and another method I've written to write it back.
Okay.
I've used map, hash map where the key is certain text, a string actually, and the value is an array list. Okay, and based on that, I'm gonna do a check update, check out, and all those things. So this is the member, this thing, and this is the catalog class. Okay, not important right now. This is what is important.
Okay.
This is the interface where I have written two methods: get records and update records.
Sure.
Then I have come to implementation
Sounds
of
good.
that.
Okay.
In the implementation, which is an abstract class, I have not really directly implemented these methods.
Sure.
Rather, I have done some of the common functionalities that I'm going to inherit in the children.
Okay. We'll look at
The major-
we'll look at that kind of pattern in DAO. So you will see them in JDBC. All of these concepts that we have learned, we will use this base DAO class. That's where I'll close all of the connections, etc. So go ahead.
Okay. So yeah. So then what I've done is I've created one extension for the catalog
Okay.
and another extension for the member.
Sounds
In
good.
the catalog, I have created one. I've made the real implementation get records of this guy. That is implemented over here.
Okay.
And in the member also, there is an implementation, the same name.
Sure. Makes sense.
And in the file, I have really just called them, instantiated them with FA and FA2. And in one case, I'm basically just getting the members, getting the whole bundle of records. And after doing some processing, which I'm not doing any processing, I'm going to do the processing. I'm just updating back. Okay. So what I'm doing is, so now is this this thing? What's that called? Your compliant. What you said before, polymorphic compliant.
I like few things.
I'm using the same.
I like
using the
your
same method. Yeah.
I like your thinking. I like your implementation. Okay. Really well. I mean, it looks like you understood the concepts pretty deep. You know, the way you are using map of string of list of string. That's pretty good. I mean, there's a data structure called multi-map in some utilities. It's pretty about the same. So I'm very happy with all of that. Few comments quickly. One, we don't follow this convention. Maybe you are getting this E01, E02 from database side.
No, not from there. Actually, in order for me to have them one after another, so as to be able to see them, see the dependencies one after another, like 2, 3. That's why I gave those names. But those are bullshit names, actually.
Got it. Yep. Shouldn't be. I mean, that's one small one comment. I wouldn't definitely put it. I rather have my object names more meaningful, more real world, etc. But you put very well. And the next comment I have is, I like your implementation of, you have this common abstract class which is doing reading from the file, writing to the file if you have given a list of strings, etc. I like that approach, but I have reservations on that approach, meaning it looks to me at the very onset more procedural than object oriented. The reason I'm saying that is because you wanted to reuse all of this. That is why you went with one single approach. That list of strings, probably I want to see that as members. I want the objects to be floating in the object world. I want to see more of that. So the list of strings, each string is a member here. What is that? Map of string of list of strings.
Each list is string. See this one actually. See, this one contains a record.
Right.
The string is the ID, and this is basically the rest of the columns in that same record.
I got it. I got it. So what I wanted to
So
say,
it's like this, Venkat. What he has is suppose he has a book, and the list of strings is basically describing about what is the ISBN number, or who is the author, and name, yeah, all those details he has put it in.
That's what, is that right?
Yeah.
Okay.
Yeah, she explained it right exactly.
Okay. It's more procedural, then I don't like it. Then, I mean, I think that's where I was going to, kind of. Thanks, Jyoti, for pitching in. So, what I wanted to see is, I don't want to carry my database representation. I don't want to carry, today you happen to put them in files. That is why you carried that kind of implementation there, okay? But limit all of them and give me, and when I ask you to give me the members, give me the members. Don't give me the string of list of strings, meaning inside this you have it, go figure out yourself. No, you figure out. That is where we'll talk about the pattern, DAO pattern. So don't leak the implementation details into the caller. Rather, you localize all the details, you embrace in yourself, okay, and make me ignorant of the implementation and give me the list of members. That is what I wanted to see it. The contract has to be, the high-level public contract has to be so clear that when I say list of members, that is what I wanted, right?
So this contract.
Exactly. I agree that you will not be able to use your nifty idea of, commonizing this one, but I'm okay with that. But if I have the reason I'm saying shown is that you have your public API, right? Your public API should say that, hey, give me all the members, then you are giving me the list of the member objects. So I don't have to figure out that, in the list of strings, the first one is the ISBN, the second one is the name, third one is this one. You are making me know. So you are making me know your database structure, making me know your file structure. I don't want to know that. You parse it. You take care of it. The reason I'm saying is, tomorrow you change from file to relational database or to something else. You will change it again. And don't make me change at that time. You and I should have, meaning the caller and the service provider should have a high-level public API without having to leak any implementation details. If you did not understand this, I'm totally fine, Sean, because that is what we will spend hours on it. Whatever I just said, all of you people, if you didn't understand it, don't worry, because I'm going to repeat that probably 50 times in the next. That's my mantra. Public API, interface. That's what I meant. All the way till the web services, you will see me. You will hear me say that. Okay? Did you get a little bit of my point?
Yeah, some point. Yeah, in fact, while writing it, I felt a little this thing. I mean, I was not. See, this is a very crude thing. I know that. So all I wanted to.
It's more not only procedural. Actually, even in procedural world, you can make it probably much high level interface. Yeah, this one you are giving me the raw information, and you are making me parse again. Parse again. If this is your implementation, I'm totally fine. What you do is, add another layer of abstraction. Don't make any of this public. Whatever you wrote is totally fine, but put a wrapper on top of it and provide a public API. That's all I'm saying. Meaning nobody other than this particular package, should worry about whatever you're doing under the hood. You get it?
Okay.
I mean, I don't expect you to really get it, Sean, now,
Right.
but this is what we talk about in the next, okay?
Okay, but only thing that I wanted to make sure was, see whether it is polymorphic.
It
Whether
is
this
polymorphic. That's what I'm saying.
Okay? Yeah, that's the thing that I wanted to grasp actually.
You got it. No, how do I say that? Kind of polymorphic.
So Shravan's point is he has get records and update records, so two methods, correct, within the interface. And those two methods he is calling to update the to get the records and update the catalog and also the members.
But I'm not using different codes for that. I'm using the same words.
Code,
get
but
records.
in different ways he is using it.
Yeah, but it's going there and looking for it in the corresponding extension. In that sense, is it polymorphic or not? That's all we wanted to know.
In a way, yes, but the reason I'm saying is that your member, you need to, how do I explain at this point? So it's definitely one way of doing it, okay? But I definitely do not recommend in my project.
I understand, but
Okay.
no, the polymorphism issue. That's
Yeah, polymorphism, I see it. Yeah, I do not approve this design for the fact that being able to get member information and two discrete pieces of information. So two discrete pieces of information, here member information and catalog information. You can definitely, two discrete pieces of information, right? You have member information, you have catalog information.
coming from
All
two
of
different
this,
levels, yeah.
see, member information itself coming from two different sources, that is where I want to see the polymorphism actually. One
No,
coming
member
from
information
file,
coming from one source only. That is one file.
Right. You are using it in a way, I mean, that's what I'm saying. Java definitely lets you do it. But I'm not convinced fully sure. The reason is it's a two different. I'm not happy with the API. I'm sorry though, right? You want the honest feedback, right?
Yeah.
There is something
Don't worry about me.
There's something called domain-driven design. Okay.
Okay.
In the DDD, domain-driven design, there is a big book on that actually. Eric Evans wrote that book. So, anyways, in the domain-driven design, domain objects are the key. Okay. Those, if we really go deep into it, they are supposed to be rich domains, not anemic domain, etc. So, I wanted to use the polymorphism in a way that the data is coming from two different sources or two different implementations. So what I wanted to say is, in the next class especially, you will understand more. Maybe not next class, 3 classes down the line. So you will read this data, this member information from database, from relational database using JDBC. That is one implementation, right? Now, the same member information, you will implement it later on using another implementation called Hibernate. Or another implementation called file storage. Okay? So, in one case, I'm reading simple IO, like your approach, and populating it. In other way, I'm using relational database and using JDBC and populating it. In other format, I'm using Hibernate and populating it. So I wanted to, so there are some design principles which I cannot talk about it. Okay. One of the principles is that there are 5 principles: solid, SOLID. Single responsibility principle, open closed principle, interface segregation principle, Liskov substitution principle, and dependency injection principle. Okay. So one of the principle that's where I'm really getting into topic that I don't want to.
Okay, no
But
problem.
the point
6
is,
minutes was the limit anyway.
but the point is that when you use polymorphism, you can use definitely this way, but you want them to be swappable is what Liskov substitution principle says, that L stands for that. So you need to be substitutable, your implementations to be substitutable. So that is where I'm having little hard time of, I see your niftiness, but do I want to call it a polymorphism there? That's where I'm having reservations. You know what I'm saying? I like your thinking. I like your coding. I like your logic there.
That's okay.
But not there yet from the polymorphism perspective. I wanted to say that because I will show you more examples of it. Okay, we will do it in the class. So we will do customer DAO and orders DAO using JDBC. Okay.
Okay.
So later on, for the same one, we will do using Hibernate. So your DAO, your interface will be same, Sean. You can use either of the implementations. Okay. I confused probably heck out of everybody.
Yeah. Actually, there's a lot of things. Those things have happened long ago, and that's the reason I'm taking this course again. I mean, so
no, that's what I'm saying. You are. This is one way to do it, and definitely I like it. But wait for 2 more classes, and I want to see enhancements in your program to provide a good high-level public API. And your extends that abstract, right? That one definitely I like it, and I would definitely do that way, because we are also going to do the same thing. So we have the customer DAO, and we have a customer DAO impl. You have these opening the connection, closing the connection, etc. All of that stuff will be stored in that. I mean, I can definitely say yes, I like it, and go away.
no, that's not what
I would have done, and I would have probably made you happy also. But I wanted to, rather than making you happy, I wanted to give right information, right, as much. And a lot of designs are subjective,
Correct.
A lot of things, it depends. That's why the lot of questions you don't get black and white answers. The answer is for that is depends. The reason is, depends on a lot of things. Trade-off. Design is trade-off actually. Okay. Long story short, I like it, but member and the other one, I don't want to combine it. I don't want to combine the 2 different business domains into that. Is my point. I will leave it at that.
Okay. Okay.
Does that make any sense?
Yeah, that means it'll be. That's what I think that's what I started with in my this one, where I made what in the interface I kept 2 interfaces. That was one interface for get catalog, and another interface.
I mean, see, hold on there. Yeah. My point, I think I'm getting there. I know I'm having 18 people here, including me. Okay, I'm telling everybody that please don't get confused. First of all, with all the jargon that I've used, I'm sorry about it. And number 2, don't get scared. We will be talking about it, but now I will rephrase whatever I said in a little different way, in a language that we all can talk. Get all members. I don't want to see map of string of list of strings. That is my absolute statement. No. Show me the same thing. Whatever you just opened was a beautiful example. All I wanted to say is I wanted to see the objects. You gave me the list of strings that is not a public API. How I think that's the best way I can say it. See it, get catalog. 1 second. Don't hang. Leave it there.
I'm coming there. Yeah.
Can you give me the control?
Take it over. Yeah. Tell me what I have to do. I'll give it to you.
Yeah. Give me the control.
Okay. It's yours.
I apologize everybody for all of that confusion, right? I mean, I wanted to say some right design principles, but
what you're saying is
not
according to me.
See, no, wait.
Older version. This is my less improved version. Okay.
Exactly. Here, right? Okay. Show me the older one. The newer one.
The newer version.
Newer
version is this one, where you go.
I want to see your interface.
This one is the interface.
Okay. Yeah. Where is your public API? This is good. This is good from your file access perspective. But where are I want to see your domain objects. Where are you giving all the members? Show me.
Giving all the members means?
When I ask for all the members, right?
Yeah. Oh, when you ask for the members, you're getting here.
Yeah. This is exactly what I'm saying. I don't want to see this. Simple. I don't want this get records. This is catalog. Okay. And I don't want to say that file access. I mean, that's fine with it. Okay. See this get records. I want to see the catalogs here. You do all of this massaging within yourself. I'm fine with all of this. I will show you a very, very clear example of what I'm saying in the very next class. I can actually written the result set, but I will not. I will loop through the result set and I will extract whatever I want to it, whatever I need it, and I will expose an object. Okay. That is what I wanted to see that. Okay. Leave it.
Okay, let's leave it there.
We'll talk about it. Let's leave it there.
Yeah. Okay, no problem.
Okay. Yeah.
Thanks anyway. Sorry for holding you up.
No. Actually, I'm sorry for all the people waiting here. I may have given more information than I need to. Sorry for that. Okay. But there is it's a very, very bad time to talk about it. But there is a few principles that we will talk overall. Okay. I mean, in this course. Okay.
Okay.
I'll probably point to some reading material, some references where I can't go beyond certain point. But okay, I think let's leave it there. Actually.
Okay, no problem.
Let's leave it there. If you still can't sleep tonight, probably I can. What I'll do is I can. If you still can't sleep.
One, yes, I basically, tried to take it from there. I've got a copy of that.
See here, when I ask you to give me all the books, 1 second.
Okay.
When I ask you to give me the books, okay, all the books, you just give me the list of book objects.
Correct.
You don't tell me, you don't make me loop through your records. Probably you are going through the same file that you just showed me. That can be the implementation, but don't make me do it. You do all of that and you give me the list of book objects. How come it is not this simple is my point. That's all. Now I will leave it. The implementation can be as complex as you showed it to me. But why do you make me worry about, I will give you all the fields. Here I can say that, hey, in the book database table, okay, I have all of these columns and maybe I'm reading from the file like you are reading. I can make the user know all of this one, right? Hey, I'll give you all the fields, you figure out. Not good design. look at this interface versus that one. That's all I'm saying. Got it?
See the interface, to me the interface looks the same.
I mean interface meaning, now see here, I want to see this one. Get catalogs. Give me the list of catalogs. Why not? How come it's not easy? Simple. Tell me. Give me the catalog objects. How you get it? Sure. Go to the file. Go to, internally you are doing a list of, map of list of strings. Absolutely. Go do it. But you know that the first one is your ISBN number. Second one is your book title. Third one is author name. Okay. Don't make me do it. You do all of that stuff and give me the list of catalogs or list of books. Now I will leave. Okay. Make sense? Okay. If not, so make sense.
You really produce the IDs basically. This one should produce the IDs.
And then, no, it's beyond that.
Okay. Then there is so much I'm not understanding right now. Maybe we'll see later.
Right. I mean, yeah, we'll see. Okay. So long way to go.
No problem.
Take care, sir. But
Thanks.
I'm very impressed, and I quickly became a big fan of how sharp you can think, how deeply you can go and do it. I'm very impressed.
Thank you very much.
Okay.
Okay, no problem.
Okay, take care, guys.
Okay, thank you.
Good night, everybody. Bye.